Today we're going to go over some challenge problems from Chapter 14. So let me go ahead and jump into the first problem. Lim Industries has an average variable cost of $1. So average variable cost equals $1. It's got an average total cost of $12. And this is happening at a productivity or quantity of 500. The firm's total fixed cost, so they want fixed cost. If we remember that average total cost equals average variable cost plus average fixed cost, we get $12 is equal to average variable cost of $1 plus X, and X in this case would be $11. So we know that average fixed cost equals fixed cost divided by quantity. Using the numbers that we just derived, we're going to say average fixed cost is $11, which equals fixed cost is what we're solving for, divided by 500, because that's the quantity that we are at. If we cross multiply, we get fixed cost is equal to $5,500. So the right answer here would be C. Okay, let's go on to our next. Here we're asked, why doesn't the total cost curve begin at an origin of 0, 0? Well, remember that total cost is going to be our fixed cost plus our variable cost. It is true at a quantity of 0 that variable cost is going to equal 0, but fixed cost is always going to be positive. And so our right answer here would be fixed costs are positive when output is 0, or B. Moving on to our next problem. Suppose that for a particular firm, the only variable input to the production cost or process is labor, and that output equals 0 when no workers are hired. In addition, suppose the average total cost when 5 units of output are produced is $60, and the marginal cost of the 6th unit of output is $120. What is the average total cost when 6 units are produced? So what do we know so far? So the first thing that we know is we know that variable cost is only going to equal labor. Secondly, we know that average total cost at 5 quantity is going to equal $60. Okay? That means then that, and again, our third thing that we know is that our marginal cost at 6 quantity is going to equal 120. Okay, so what I want to find out here is what is the average total cost at 6 units. So that's kind of what I'm trying to find out. So from the information that I've gathered here, I know that marginal cost is equal to the change in total cost divided by the change in quantity. So I'm going to say 120, that marginal cost, is equal to the change in total cost divided by the change in quantity, which would be going from 5 to 6 units, or 1. Again, I can cross multiply here and say the change in total cost is going to equal 120 as I go from 5 units to 6 units. So I'm going to take my average total cost and now work with that. My average total cost is equal to total cost divided by quantity. I'm going to fill in what I know. I know that average total cost is $60. And total cost, we're trying to solve for that. We're going to divide that by the 5 units. Again, we can cross multiply and we get that our total cost is equal to 300 at quantity 5. Now we know that the change in total cost as we move from 5 to 6 is 120. So it changes by 120. If we know the total cost here is 300, then we know that the total cost is going to be 420. Oops, 420. Okay, so at 6 units, our total cost equals 420. If we want to find out, and what they're asking us for here is average total cost, we know the average total cost is equal to total cost divided by quantity. So I'm going to say, well, my average total cost, that's what I'm solving for, is equal to 420 divided by 6, and that answer is going to be $70. So the right answer here is D. Okay. Cool. Okay, so here we have a firm whose variable cost is only labor, and we're going to deal with 4 units of production. Right now, the total cost of 4 units, so quantity equals 4. The total cost equals 175. Average variable cost equals 33.75. And we need to know average fixed cost at 10 units. So what we're first going to do is because this is average variable cost that we're given and they're asking for average fixed cost, easiest thing to do would be to turn total cost into average total cost. How do we do that? We know that average total cost is equal to total cost divided by the quantity. So therefore we know 175 divided by 4. If we do that, our average total cost ends up being 43.75. We're given the average variable cost equals 33.75. So we know that average total cost equals average fixed cost plus average variable cost. So our average total cost here is going to be 43.75 is equal to average fixed cost, which is what we're trying to solve for, plus 33.75, or the average variable cost. From that, we know that average total cost at a quantity of 4 units has to equal 10. Okay, so if average fixed cost at a quantity of 4 is equal to 10, then what we want to do is to find average fixed cost. So we're going to say that average fixed cost equals fixed cost divided by quantity. And so when we plug in what we know that average fixed cost is $10. Fixed cost is what we're solving for, and our quantity is 4 units. If we cross multiply here, we get the fixed cost at 4 units equals $40. Now, because fixed costs are fixed regardless of the number that we produce, right? So this is going to be our fixed cost for 4 units or 10 units. Now we want to get to our average fixed cost for 10 units. So we're going to divide our $40, which is our fixed cost, by our quantity of 10, and our average fixed costs are going to equal $4. So in this problem, A is going to be the right answer. Okay, the next problem says curve D is increasing. So let's take a look at curve D here. And we can see by the slope of the curve that it is increasing at an increasing rate. And we want to know, is that because of a diminishing marginal product, an increasing marginal product first increases, then decreases, marginal product first decreases, and then increases. So remember that the marginal product is the increase in output that arises from one additional unit of production. Because this increases, and it increases at an increasing rate, meaning it, well, I shouldn't say that, it increases, we can see that it doesn't diminish, that would be a negative slope. It's not curved, that would be these two. And so we can see that it is an increasing marginal product because of the positive slope, and more so because it's a straight line. Okay. So now we have long run total cost for firm 1, 2, 3, and 4. And Excel might be a nice way to do this, but we're just looking here solely at firm 4. We want to know the efficient scale. And remember that the efficient scale occurs at the quantity that minimizes average total cost. It's where the marginal cost curve crosses the average total cost curve. Okay, so let's take a look and see what we know here. So I think really because what we deal with in efficient scale is average total cost. So the first thing I would do is to calculate average total cost here. Remember, average total cost is just the total cost divided by the quantity. So for our first quantity, we have 210, 170, 163.33, 165, 170, we have 176.67, and we have 184.29, rounded. Okay, so based upon what we know here, where is the average of our average total cost? It's going to be somewhere in here, right? Around 3 units. So let's double check that and let's calculate our marginal cost. Change in total cost divided by our change in quantity. So I have 130, 150, 170, 90, 210, and 230. Okay, so if this is our marginal cost, and we want to look at this our marginal cost and our average total cost curve. So where is the marginal cost curve crossing the average total cost curve? Where are they pretty much the same? We would say, okay, well that looks like here, right? Marginal cost between 3 and 4 units is 170, right? Also, you can look at it this way. If we have an average, I'm sorry, I shouldn't show you that part because it's going to confuse you, I think. So I would say it's between 3 and 4 units. Here, our efficient scale, when we're between 2 units, we usually move up to the next unit. A lot of people would like to say this 170, and that's not actually appropriate because marginal cost is what we're really gauging this on, right? So we can see that the minimization of average total cost really starts to look at right here at 3, but because the marginal cost, the 170, and the average total cost are the same at 170, we go ahead to that 170, and then we say if it's between 3 and 4 units, we always round up 1 unit. Farmer Brown plants no seeds on his farm and he doesn't get a harvest. If he plants 1 bag, he gets 5 bushels of wheat, 2 bag, 9 bushels, 3 bag, 12 bushels. Okay, so for 1 bag of seed, right, what is our quantity? We get 5. 2 bags of seeds, we get 9. 3 bags of seeds, we get 12. So it says, okay, a bag of seed costs 120. His seeds are his only cost. His total cost curve is doing what? So here we can look at, we could calculate this all out, but I think it's easier if you just look at the numbers. So total cost, fixed cost, variable cost. Here his only cost is $1.20. If we multiply this out, which we could, but I think you can see what's happening. From 5 to 9 is a change of 4 when we look at the marginal cost. 9 to 12 is a change of 3. So his total cost curve is increasing, but it's increasing, and based upon the marginal cost curve, we can say, is it increasing at an increasing rate? No. His costs are increasing, but they're increasing at a decreasing rate because marginal cost curve is going down. So it is increasing because as he adds more bags, yes, his cost increases, but his marginal cost here is decreasing. So increasing at a decreasing rate. Okay. Our next one. Look at that. There we go. I have this here. Okay. Walter used to work as a high school teacher, but then for $40,000 per year, he quit in order to start his own painting business. This is going to be a sunk cost. We're not going to compute this in either one. To invest in his painting business, he withdrew $2,000 from his savings that paid 3%, borrowed from $30,000 from his uncle that he also pays 3%. He paid variable cost of $25,000 for supplies and had a revenue of $60,000. They want to calculate his, both Tyler, an accountant, and Greg, an economist, want to calculate his business costs. So this problem goes to the heart of how accountants look at costs differently than, say, an economist. So let's take Walter first. Oh, sorry, Walter's the business. Sorry. Let's take Tyler first. There we go. I'll get this right. Okay, so Tyler, the accountant, says, all right, let's see. Withdrew $20,000 from his savings. Fine. Borrowed $30,000 from his uncle at 3% for 1 period. So that's $900 in interest. He paid $25,000 for supplies. So his supplies are going to be $25,000. His total costs are going to be $25,900. He has a revenue. So remember that profit. Oh, painting cost. Okay, that's all they want is the cost. Okay, sorry. So 25,900. So we can see that it looks like it's going to be A, but let's double check with our economist. And our economist is Greg. And Greg's going to be a little bit different because what Greg's going to do is say, well, you know, you had your $40,000 a year that you could have been making, right? So $40,000 a year that you could have been making. We're going to go ahead and add that in. This teacher's job, which you're no longer making. The $20,000 that you took out of your savings account, which pays 3% interest for one period. And that's going to be $600 foregone interest. $30,000 that you borrowed from your uncle. This is going to be the same as our accountant. Is $900 interest. And we also have the $25,000 in supplies, which equals our $25,000. And if we add all of these up, what we get is $66,500. So what the economist does is really looks at everything here. And yeah, I know that the $40,000 is a sunk cost, but we're going to say that perhaps he could still be doing that, right? So that is an opportunity cost rather than a sunk cost. I kind of misspoke at the beginning. Okay, that's the end of these challenge problems. Again, if you have any questions, please do not hesitate to contact me. Thanks for your time and attention.